Hey, thank you all for joining. My name is Adrian and I'm a community manager at Cloudbase Solutions. Before we start, a couple of words from us. Together with Daniel Marino and Skylab Startup Development, we organized this meetup. I'm really happy to see as many of you here as possible. It's a big crowd. We have 3 presentations for you today. It's the OpenStack Bucharest Meetup, but if you post on social media, I kindly ask you to use the hashtag OpenStack2016. We have speakers from Timișoara, Cluj, and Bucharest here, which are 3 cities that we like to develop the OpenStack communities in the future. I'd like to also tell you a bit more about the OpenStack CE Day in Budapest. Just after the OpenStack Summit in Austin, there's going to be a big meetup in Budapest. I spoke with Martin Kish, which is the organizer of the event and the OpenStack ambassador for the region. He gave me discount codes, which I'm going to send you after the meetup. If you guys want to attend the summit in Budapest, it's 50% discount. I'm going to send you the code after the event. I'd like to give the word to Daniel Marin to tell a bit more about the sessions and present the first speaker.
Hello again. I'm Daniel Marin from Skylab Startup Development. First of all, I will present my colleague from Cluj. He is a PhD student, so he will have a presentation based on his PhD thesis. It's something regarding software-defined networking and evaluation in the OpenStack environment. Hope you'll find it very interesting. And later on we will present the other speakers. So hope you have a nice technical presentation. Each presentation in the end you will have some question, so you can discuss, and of course a networking part you can discuss with them one-to-one. Okay, Edward Lukian. Thank you.
Will I have a microphone or will I have to shout? Hope I'll manage a mic and a device. Hello everybody, my name is Edward Lucan and I'm a PhD student at the Technical University of Cluj-Napoca. And this thing does not work. Classic mouse. My background, I'm a student since 2012. I'm affiliated with the United Communication Laboratories, which is the laboratory for development and testing inside the University of Cluj-Napoca. And I'm a partner with Marian since 2015. My research area started from seamless connectivity in voice over IP systems in my master's degree diploma, and at the moment I'm researching cloud architecture regarding services and signaling in order to provide seamless services inside the cloud, basically a private cloud. The contents of the presentation is as follows. First of all, I'm going to state why I did this research. This research is based on an article that me and the team from UC Labs have published in a journal. I'm going to tell you a few things about, for those of you who don't know the concept, about network function virtualization or NFV. After that, I'm going to explain what's software-defined networking, why we chose the OpenStack. I think it's good. The test roadmap. I'm going to share with you some experimental results, conclusions, and further development of this article and of my thesis. The Spark was an SDN testbed that my colleagues from UC Labs developed. They had 9 computers in which they deployed a software-defined network testbed. They used a beacon controller and installed several virtual switches using virtual switch, after which they performed several tests by modified discharge algorithm and so on. That's their part of the SDN. What's current time? Every appliances regarding network represents mostly a hardware device. You can see on the left, you have a router for routing, a firewall, load balancer, switch, and so on. The next generation networks proposes MFV. All these functions are uploaded on a single device or multiple devices, and they are virtualized. How is MFV deployed in OpenStack? Majorly MFV in OpenStack regards only Neutron. Neutron is the network part of OpenStack. It relies on a Python daemon and plugins. Here you can see on the slide, I've particularized what Neutron contains regarding my deployment, and I used modular layer 2 plugin and several agents. The OpenStack switch agent, the HTTP layer 3 agent for routing in OpenStack, metadata agent, so I could forward data to the virtual machines, and the load balancing as a service, but I didn't use that as much. I just left it as default. Who does plugins for MFV in OpenStack? One of them are Cloudbase solutions. If I'm not mistaken, you have a plugin with OpenStack switch for OpenStack?
Yeah. That's
okay. VMware has plugins, Cisco has plugins that allow OpenStack to work with Cisco devices. In our university, we have a Cisco switch that we interact from OpenStack. Open Daylight, who their main focus is the OpenStack switch and SDN controllers in OpenStack. Software-defined networking. You can see on the slide the standardization bodies, the bad guys that detail all the direction software-defined networking takes and will take. From all the definitions on the web, I found the most interesting and the most close to our session, the 6-wind SDN architecture, which presents SDN as a network paradigm where you separate the control of the network from the hardware. You can see this SDN architecture is based on a cloud, where you have the cloud orchestration. In our case, in OpenStack, you can consider, I don't know, HEAT or Juju or something like that, an SDN controller, and after which all the virtualized network with all the devices. You can see here what is an OpenStack switch. It's an open source virtual software acting in data plane. Basically, you can do virtual switching in an environment. The Tor switch is just an equipment, and the SDN controller. I like to point from the definition of the SDN controller that it could run on a virtual server. In the current deployment, that was the case. The beacon controller was virtualized and ran as a virtual machine in OpenStack. SDN on OpenFlow. The SDN controllers, of course, must control the OpenStack switches, and it does that through OpenFlow. OpenFlow is a specially designed protocol through which an SDN controller controls multiple virtual switches and establish how the data goes, regardless of the physical paths. You can establish different algorithms based on testbed or how you know the network flow will go. SDN and OpenStack at the moment, sadly, as far as I know, SDN does not have a native system for deploying SDN in OpenStack as an architecture. At the moment, the best solution, if you want embedded SDN testbed in OpenStack, it will be using OpenStack Ironic, which will allow you to control physical switches like the Cisco switch that I mentioned earlier, using an OpenStack Daylight controller, which I think is the most complete at the moment and the most stable. And for the MFV part of OpenStack, the fastest or the most reliable MFV tool of OpenStack is Project Calico. though it's in the early development stages. So you may want to still go with Neutron and OpenBase Switch and Linux Bridge technologies for the moment. Why we chose OpenStack? Naturally, it supported all the technologies that we needed for a testbed, for the SDN testbed. It has a pluggable API architecture, so if someone will develop anything or we will develop anything, it will be very easy to implement. It's already a highly adopted cloud solution, so everybody talks about this. There are a lot of you here, so I think OpenStack is interesting and it's open source. The test roadmap, we had 3 different stages. We started from a single node deployment on a server using RDO, DevStack, and then we switched to multi-node manual deployment. I'd like to state some particularities regarding our testbed. Juno OpenStack was used because the testbed ran for several months. We wanted to see how the environment performs and how its stability is. The RDO was installed on a CentOS 07, DevStack was on Ubuntu, and the multi-node was the same on Ubuntu. For networking, as I mentioned earlier, we used Neutron with ML2 plugin with the OVS technology. This is how the SDN testbed that I presented earlier as the Spark looks in OpenStack. It may look complicated, but it's 1,000 times more easy than the real testbed. In the real testbed, we had 9 computers that we had to interconnect on switches, go start up the computer, move from one computer to another. From OpenStack, it's easy. There are virtual machines, we can start them, we can shut down, we can operate on all the machines at the same time. The single node deployment, we started on RDO on a server which we used VMware with RDO, 8 GB RAM virtual machine. We started from the basic network test, the ping. On the physical testbed, we had about 50 milliseconds, the round trip time. And between 2 instances, we had about half a millisecond. We wanted to test how good is the MPV in OpenStack. Okay, we have OpenStack, everybody talks about it, but it is feasible if you want to test something in your laboratory, or how many computers you need in OpenStack. Because in my case, I'm not a telco, I don't have a server, I don't have anything else. I have computers. So regarding the desktop, if we can use OpenStack or not. The RDO proved that you cannot use OpenStack for a testbed because the loopback was about 20 times higher the time. The beacon from the switch on was about 6 times higher, so the network was performing very poor. So that's not a solution. We switched to DevStack. DevStack was a bit better. The loopback was 90 times higher, so that was still a no-go. After studying what impacts the performance of OpenStack functions, we ended up with RAM amount. Okay, we up the RAM amount, so we switched from 8 gigs to 28 gigs. And you can see on the slide the improvement. The improvement was somewhat better, but still not comparable to a real-life testbed. We encountered some issues on the 28 gigs of RAM, virtual machines. We ran on UDP flow using ePerf at a value of 30 megabytes per second. The maximal active transfer rate was about 82 megabytes per second. So if we add in the network 30 megabytes per second flow, the active transfer rate should have dropped down to 50 megabytes, but it did not. The network function virtualization of the OpenStack did not listen to our command of the hyper flow. It only dropped about 9.70 megabytes per second. So it was still not a solution. Another issue that we encountered on our deployment was the latency in the terminals of the instances. If you worked in instances with OpenStack, we encountered latency. We first used the regular hard drive, and this usage was frequently 100%. So we switched to SSD hard drive, and that resolved the problem. No more latency in the instance terminal. So if you want to deploy an instance, an SSD is a must. This is our architecture for the multi-node manual deployment. We switched to two computers, one that had 64 gigs of RAM and other two that were virtual machines. Here you can see after the installation what agent list and what services ran on the OpenStack installation. Here is the overview of the machines running in OpenStack. I don't think you can see. The first machine is another machine that did not appear in the SDN testbed. It's a display controller. We use display controller to chart out the graph we saw before with the hyper. And then we ran the test again with the ping result. The ping result in this implementation was actually better than in real life. So okay, with this hardware configuration, we can run a test bed in OpenStack. You can see the loopback was half of the real time, as well for the ping result between two machines. Here you can see how the interface of the beacon controller. The beacon controller is the SDN controller that our laboratory uses. It's written with algorithms implemented in OpenFlow. We still encounter some issues with this deployment. The beacon controller did not saw the virtual switches because OpenStack did not forward multicast package, the link layer package, so we had to manually configure each port of OpenStack to allow MAC address spoofing, basically. After we saw that it's a feasible implementation, we wanted to see effectively what's the relation between RAM and the MPV performance in OpenStack. You can see at about 32 gigs of RAM on a compute node, that's the benchmark that you have to reach in order to have similar performances on your virtual machines regarding network performance in OpenStack. So after 32 gigs of RAM, you can use OpenStack for testbed in the same way you would use a physical testbed, but the costs are way lower. In conclusions, I want to say that OpenStack is currently an option for MPV and SDN in various deployments. Even though hardware resources dictate the scalability of the testbed, we only had 10 machines in this SDN testbed, but the hardware resources are not so pricey that you cannot scale up, I don't know, to 100 machines for a testbed. After this testbed was proven that you can use OpenStack as a testbed, our university is involved in the Histera program in a project called Dionysus, Declarative and Interoperable Overlay Network Applications to System of Systems. We want to use OpenStack in this. What's the Dionysus context? It's foreseen that in 2020 there will be about 50 billion devices that will connect, that will have different technologies, that will work with different applications, that will have centralized and decentralized management. And that, in that way, the current network infrastructure cannot bear with so many devices. The challenges in this project, the main thing is to think global, to think at a global scale, what the implications will be, what the devices will be, what the demands will be, but to be able to act local, to make a local management of everything. In the analysis approach, every aspect of today's networks and today's interoperability of systems will be abstracted to the software level. So for that, the applications will need a solid and flexible environment in which to develop, and that is OpenStack in our approach. This project involves 4 different universities: the University of Cluj-Napoca, Lancaster, University of Bordeaux, and University of Neuchâtel. We at the Technical University are mainly responsible of the infrastructure and OpenStack. Here you have references of the first references is the SDN testbed and what where it all started from. There you can read more details about the Spark. And in the end, I want to acknowledge that a more detailed presentation regarding the exact values of our test will be available in the Acta Technica Napocensis of 2015. Okay, thank you for listening. Any questions, if you have, or any interest? Okay, please.
Yeah, I'm pretty new to OpenStack. I've only been looking at it for the last 2 weeks. So, thanks.
Okay.
So basically my question is, I want to make sure whether I understood correctly your project. So you use OpenStack to deploy an SDN network virtualized inside OpenStack. Yeah. Okay, and the question is, the UDP string you sent with iWork and the ping latencies, those are all calculated inside SDN, inside OpenStack?
Inside SDN, inside OpenStack. But if we wanted to perform SDN tests, the SDN tests are the responsibility of my colleagues. If we wanted to perform SDN tests, we had to obtain at least the same performance of the network inside OpenStack. And OpenStack offers the performance after 32 gigs of RAM. That was our conclusion.
Okay, so basically the comparison is between the ping latency of the OpenStack network itself and the ping latency through the SDN through OpenStack.
No, the comparison is between the SDN network in real life, the real testbed,
okay, so
with
physical hardware,
and the network function virtualization in OpenStack.
Okay, thanks.